Come back. We're on problem number 7. Let's see, they drew a triangle here. Let me draw a triangle here as well. This is the height. This is drawing the triangle. Drawing a triangle. Okay, so and then let's see, drop a looks like an altitude like that, like that. This is a height h. This is perpendicular x, y, z. They say in the triangle above, xz is 6/7 of h. So this right here is 6/7 h. The length of the altitude, right? H is the length of the altitude. What is the area in terms of h? Well, area is equal to 1/2 base times height, right? And what's the base? Well, 1/2 times the base. Well, the base is 6/7 h. 6/7 h. And then the height is h. H. So times h. So this equals, let's see, this 2 becomes a 1, this becomes a 3. So I get 3/7 times h squared, which is choice B. They wrote it as 3h squared over 7, but we know that that is the same thing. So that is choice B. Next problem. Problem number 8. If a and b are positive integers, and they say a to the 1/2 power times b to the 1/3 power to the 6th power is equal to 432. What is a times b? A times b is equal to what? Well, let's see what we... Here I just try to use exponent rules and play around with this as best as I can. So if I raise a product of two numbers that have exponents and I raise it to an exponent, that's like raising each of these to the exponent. So that's like, this is the same thing as a to the 1/2 to the 6th times b to the 1/3 to the 6th. And then when you raise something to an exponent, then you raise that to an exponent, you just multiply the exponents. So that's the same thing as a to the, what's 1/2 times 6? That's a cubed. And what's 1/3 times 6? Well, that's b, that's 2, right? 1/3 times 6 is 2. So that's a cubed times b squared is equal to 432. And then we could even write this as, a times a squared times b squared is equal to 432. And then this we could write as a times a b squared. I'm just playing around. I actually don't know if this is going to get me to the problem. Is equal to 432. So this is interesting. We want to figure out what ab is. So if we can divide this expression by some number, some integer, and get a perfect square, then we're essentially done. So what happens? Let's just try to divide it by 2. What's this divided by 2? If you divide it by 2, you get 216. Is 216 a perfect square? Well, let's see. What is 16 times? See, I forget. 16 times 16. 6 times 6 is 36. 9 and then 160. No, that's 256. That's 256. So that's not just 256. And let's see, 14 times 14, that might be it. 14 times 14. 4 times 4 is 16. 1 times 4 is 4 is 56. 0, 140, that's 196. So it's no, 216 isn't a perfect square. Well, what if we, let me erase all of this. Let me erase this. As you can see, I don't do these problems ahead of time. I do them in real time for your benefit. Okay. And I don't even know if I'm going down the right route. I'm just taking it cold like you will when you're in the mix of things. So let's see, what other numbers are there? Let me make sure my pen is right. So let's see, is this divisible by 3? Yes. What happens when 3 goes into 432? 432 into 3. It's 100. Remainder 3, 13 goes into it 4 times. 4 times 3 is 12. 12, 12. Oh, look at that. That's a perfect square. So we could write this. That's equal to 3 times 144. So AB could be 12, right? How do I know AB could be 12? Well, if we set A is equal to 3, if we set A is equal to 3, if A is equal to 3, then AB squared, then this whole term is going to be equal to 144. And if this whole term is 144, then we know that AB is equal to 12. And that's choice B. And, you could have done it the other way around. You could have actually looked at the choices and tried to work backwards. I kind of fumbled a little bit trying to figure out, well, how can I write 432 as the product of a perfect square and some other number? And you could have tried each of the choices, squared them, and tried to see if they actually went into 432. And also met the other constraints that A and B have to be positive integers that are different, etc., etc. And of course, if A is 3 and AB is 12, then of course B is 4, but we didn't have to know that. All right. Next problem. Invert colors. Okay, problem number 9. What is the greatest 3-digit number that has a factor of 10? That has a factor of 10. What is the greatest 3-digit integer that has a factor of 10? Oh, okay. That has 10 as one of its factors. For some reason, when I read that, it just didn't register in my brain. So I'm looking for the. So first of all, when they say 3-digit integer, so this is, we're essentially saying any number. So let's say x is our integer. So it has to be less than or greater than or equal to 100. It has to be less than 999. And we essentially want some number in this range that has 10 as a factor. Well, what do we know about things that have 10 as a factor? They end in 0, right? 10, 20, 30, 40, 50. All of these, they have to end in 0. So what's the largest number that's less than this number that ends in 0? Well, 990. And that's our answer. Problem number 10. Maybe I don't have to clear this. I can just do it right here. Problem number 10. A recipe for chili for 20 people requires 4 pounds of beans. So 20 people requires 4 pounds. At this rate, how many pounds of beans are required to make chili for 150 people? So we can make a ratio. 20 is to 150 as 4 pounds is to x. Right? I just say, I'm just kind of, whatever factor I have to multiply 20 by to get to 150, I have to multiply the same factor to get to x. And I just set up a ratio. And if we cross multiply, we get 20 times x, right? 20 times x is equal to 4 times 150. What's 4 times 150? It's 600. Divide both sides by 20. 600 divided by 20 is 30. We need 30 pounds of beans if we're going to do it for 150 people. The next problem. Problem number 11. I'll switch colors. When the positive even integer n is positive and even, is increased by 50% of itself. So plus 50% of itself. The result is between 10 and 20. So it's between 10 and 20. So 10 is less than n plus 0.5n, which is less than 20. Right? That's what we know. What is one possible value for n? So let's do a couple of things. One, we can simplify this. What's 1n plus 0.5n? That's 1.5n. 1.5n, and that's actually, I'm going to write it as a fraction. That's 3/2 n is greater than 10, which is less than 20. And then what we could do, this is an inequality, right? So we can multiply every term of this inequality by 2/3, right? So 2/3 times 10 is less than 2/3 times 3/2 n, which is less than 20 times 2/3. So here we get 20 over 3 is less than, this cancels out, n, which is less than 40 over 3. And 20 over 3, this is like, 6 point something, it's a little less than 7, is less than n, which is less than 40 over 3. This is like 13 point something. So you just have to pick any number between essentially 7 and 13. So n, 7 is less than or equal to n, which is less than or equal to 13. Any number you pick between that range would work. So 10 would be a good number to write down. And a very easy way of doing that problem is just trying out 10 and seeing if it worked out. And it would have worked out. Anyway, I have 10 seconds left, so I'll see you in the next video.